Yeah, right about that.
And we're back.
Continuing on from last day, position versus time. Sarah, my angel, if I gave you this graph, this position in centimeters versus time graph, first of all, can you tell me, any of you, hey, what's the slope of this? Now, by the way, Jake, I made these numbers up. You'll notice they go exactly in a nice straight line. In real life, when you're timing stuff by hand, human error creeps up. Often in real life, don't write this down, Emily, often in real life, you'll get like that, like that, like that, like that, like that, and you kind of draw a best fit line that goes, kind of splits the difference as best you can with a ruler. So I should point out then, I'm making up numbers. Hey, analysis of motion. Folks, what's the slope of this? You can go between any 2 points. If it goes through 0, 0, I almost always use that as my first point. And, oh heck, let's use that as our second point. What's the rise? 100? Over? What's the run? 5? What's the slope? Hey, what's 100 divided by 5, boys and girls? 20. And by the way, you notice if I was really clever, Sarah, I could have gone from here to here. What's the rise? 20. What's the run? 1. And I can get 20 over 1, 20 in my head. But I get the same answer no matter which points I use. The slope is 20. Positive or negative? Let's put a little plus sign just so that we know that we remembered that. If you don't put a plus sign, I'll assume it's positive. But let's put that in our notes, Hannah, so that we remember that we thought of that. What's the velocity? What's the slope? What's the velocity? 20. I got to be careful. Now I got to do units. So velocity is a vector. Positive 20. What are the units? What are we measuring? Centimeters per second. This time not meters per second. Okay. Jessica, I can't add more of a direction than just the plus, because I don't know, this question didn't say that positive was north or east or right. I don't know. I'll just positive. There's my direction. Okay, there's my analysis of the motion. I found the slope. I said the velocity is positive 20 centimeters per second. Oh, wait a minute. I can give you a direction. There is a direction. What is the direction on the y-axis that they mention? I can be more specific. So on your test, which is in a couple of days, I'm going to give you some graphs and I'm going to say analyze them somehow. If it's a position time graph, the slope is the velocity, rise over run, uphill positive, downhill negative. Next page. We can fill this in. We've already covered some of this. A blank line has 0 slope. What kind of a line begins with the letter H? Horizontal is the fancy schmancy word. I'll abbreviate it, horiz. This indicates that the object is what? Stopped. And for those of you that take physics next year, I'll include the fancy word that we always used in Physics 11. We say it's at rest. Object is at rest. That's what stopped means. Does that make sense? Sarah, here's what this graph is saying. This graph is saying after 1 second, you were 2 meters to the right. After 2 seconds, you're still 2 meters to the right. After 3 seconds, you're still 2 meters to the right. You know where you are after 4 seconds? Still 2 meters to the right. That's the definition of stopped. You're not going anywhere. So in terms of the analysis of motion here, velocity equals 0. And this one is meters per second, not centimeters. I looked at the y-axis. The other one was centimeters, wasn't it? Yeah, it was. Okay. Negative slope slants down. Indicates motion in the direction of the, well, if we wanted to get fancy, we would say negative y-axis. It's backwards, or down, or left, or west, or whatever situation, Leah, that you want to come up with. The question will give you more information. So here, tell me about the motion of this particular object. Are we at rest? How do you know? So if I gave you this as a multiple choice and one of the answers was v equals 0 or at rest, you'd cross that out right away. You'd cross out any positive answers. Why would you cross out any positive answers? Okay, it's a negative. Speaking of, what is the slope? Okay, this one's a bit trickier because there's some decimals here. Let's find between this point and this point. I always try and do 0 high if I can because I do math better with zeros. Hannah, you already said negative. Yes, I heard you. Or was Jake? What's the rise? How high are you when you started? 1.5. And where I put this dot, how high are we? How high are we? What's the rise? 1.5. Technically negative because we're going down. I already got the negative, yes? Over. So, Hayden, there's the rise. There's the run. What's the run? What do you get when you go negative 1.5 divided by 0.6? Sorry? Negative 2.1? Even? No decimals after that? Like even? Okay. Units. Oh, sorry, that's the slope. Now let's answer velocity. It's negative 2.1 units. Is it negative 2.1? People are... Did you say 2.1 or 2.5? Okay, that's why I was questioning you like crazy, going, that doesn't seem right. Negative 2.5. Thanks for correcting me eventually. Never trust Miller again. Yeah, that was my first mistake. It looks like the units are on the y-axis meters, on the x-axis seconds. What if on the x-axis it said minutes? What would my units be? Meters per minute? What if it had kilometers per minute? Yeah, I could do that. Our preferred is meters per second and kilometers per hour, but I'll work with what the graph gives me, usually. Or I could say this. V equals positive 2.5 meters per second. Left. That contains the negative. Right? No, left. Mr. Doak, do you like spend hours making these up? You must.
Roger.
Patience, Dana. Turn the page. So let's look at some examples here. I wrote down here, describe the motion of this vehicle for each section of the trip. And I decided to call each time it changes, I called it A, B, C, and D, so I have some kind of a reference. So here's what we're going to fill in. From A to B, Heads, which direction are we traveling on the stretch from A to B, and how can you figure it out? I see that direction. I don't know. Huh? This graph, for some reason, is going to let west be positive. They decided to do that, then I'm going to go with that. So it says position west, which means, I guess, west. See where we got that from? On the y-axis. At how fast? How can I figure it out? Word that begins with the letter S and rhymes with ope. Okay, I'm going to find the slope. So I'm going to do my little slope triangle here. Here's my rise and my run. My rise is what? My run is anyone but Miller. What is 2 divided by 5? Okay. 0.4 meters per second. We're going to do that for each remaining line, but I don't want to write quite so much. So instead of from A to B, I'm going to go like this. B, arrow, C. Is that a good way to abbreviate, Amy, from A to B? I think so. Comma. What's happening in section B to C? At rest, you can write stopped, but I'm going to write the physics word. C to, and by the way, I didn't include a direction there because at rest has no direction. But C to D, are we at rest? No? Head which way? Do we have an abbreviation for the word at? I think we do. In our email addresses, so we'll use that. How fast? What's the rise? I heard it. Huh? 7, isn't it? 1, 2, 3, 4, 5, 6, 7. Sorry, what? Now, I can't say -7. Since I said east, I think that's going to include the negative. Or if you said negative, I would be okay with that. But east in this graph is negative. The rise is 7 over, what's the run? Well, first I have to do a better drawing than that, Mr. Dewick. 1, 2, 3, 4, 5. 7 over 5, 1.4? You could say negative or you could say east. Okay. I don't want to say negative east because wouldn't negative east actually be west again? So I don't want a double negative, just like in math, a minus minus kind of means a plus. Okay. Next one. Last one, I think, yeah. Describe the motion of the car on this graph. You know what? Let's do the same trick. Let's call this point A, point B, point C, point D, point E. By the way, what are we graphing on the y-axis here? What word did I use? Distance, scalar or vector? Who remembers? Scalar, so I really couldn't give you a north, east, southwest. Oh, but look at my graph. Am I ever going negative in this graph anyhow? Oh, good. So we can relax. Yes? So from A to B, find the speed, please. From B to C, find the speed. From C to D, find the speed. And from D to E, find the speed. See if you can do this on your own. I won't freeze my screen. I'll do it up here, so if you get stuck, look up. But let's see what we can do here. Am I wrong? Have I made a mistake?
Oh, yeah.
I don't think I have. Is what 0.75? Oh, is your height 75? Oh, not 80?
I got it. No, I wasn't. I didn't even look up.
So on your graph, I didn't even look.
Incorrect.
On your graph, do I have a picture of this one, Mr. Dewick? I probably didn't bother because this one seemed very... Can I borrow your paper for a second, kiddo? Thank you. Oh, yours is definitely halfway. Okay. My graphic has gimped when I've stretched this. So let's fix that, Mr. Dewick. So are you guys then finding that it's 75 over 0.75, which is exactly 100 kilometers per hour? Yeah, okay. I'm right on the second one, on the next one, though, am I not? No, I'm not. Then it would be not a distance of 10. It would be a distance of 15. $60? I got CD right, yeah? Whew. Okay, Mr. Dewick, DE. Does your E go halfway between the 120 and the 130? Okay. What's my rise? 125 and 90. What's my run? Is that right, Mr. Dewick? Rise is 10, 20, 35. Yes. Run is 3/4 of an hour. Each square is 1/4 of an hour, so it's 0.7. I think I'm right. Is that correct? Any you want me to do where you're going, Mr. Dewick? I have no idea how the heck you got that. I will happily explain it. This is what you're going to see on your test. I'll definitely give you a couple of graphs to analyze like this, and I'll say, hey, tell me what's going on. By the way, where is this person on the freeway? Between what letters? A and B. How can you tell? Where is this person driving through a subdivision? I think D to E, because subdivisions are curvy. You really can't drive at any kind of a speed. You're, cul-de-sacs, there's cars parked on either side. Watch for kids. I think D and E, he or she has slowed down. They're going through a subdivision. Where are they driving on city roads where they've got 2 lanes and they're okay, but they're not worried about little kids? B to C. Okay. So here's B to C. Here's D to E, about that steep. What would a school zone look like?
Put your left arm down a little bit.
School zone, right? Some of this, hopefully, when do you guys go for your driver's test? Is it this year or next year? You need to start learning some of this, so I'm trying to throw as much as I can in. If you take physics next year, we'll also talk about the physics of driving and how many of you just don't realize how weather and friction play a part in your driving. Put your pencils down, look up. So, average velocity, I already did this. I'm going to blaze through this really, really quick. You are going to want a calculator out. If you don't have one, come borrow one right now, really, really quickly. I have 3, leave me some, oh, no, it's a lie. I have 1, 2, 3, 4, 5. Leave me some collateral. No, I have 6. Leave me some collateral on the science card. A pencil, really? Depressing. Headphones, a little better. We've been live for about 30 seconds. The relationship between average velocity, displacement, and time is given by, we said this. Here is how I remember it. Velocity is displacement over time. Technically, change in displacement and change in time. So you can put the little deltas in front if you want to. How do I remember? Now, it's on your formula sheet, but I just know how speeds work. What's the speed on the freeway?
80.
100. 100 what? Kilometers distance per divided by hour time. The formula is built into how we talk about speed. There are 3 ways to express this formula. You can also rewrite it to get the distance by itself or the displacement by itself. How? What's the t doing to the letter D mathematically? Adding, subtracting, multiplying, or dividing? Dividing. So how would I move it over to the other side? What's the opposite of dividing by t? Okay. Sorry? What's that thing beside the... Oh, yeah, it's my writing. I can also get the t by itself. From this equation, how would you get the letter t by itself? Well, there's a v sitting right there. What's the v doing to the letter t mathematically? So how would I move it over? Turns out time is distance divided by, displacement divided by velocity. I've always, Curtis, done this mathematically because I'm a math nerd. Apparently, some teachers teach this. I hate this thing, and I'll be honest, I don't even know how it works. But I think they give you a triangle, and I think they go the D there, the V there, and the T there. Is that correct? I hate them. The reason I hate them is the triangle only works if you have 3 variables, 2 of which are being multiplied. What if you have 4 variables? You need a whole new shape. What if you have 5 variables? You need a whole new shape. What if they're not being multiplied? You need a whole new shape. My argument, and if you take Physics 11, I'll teach you how to solve anything in your head. And it takes a little bit of practice, but when you have it, you've got it for life. Anyways, apparently, I guess to find V, I cover up the V, and it's distance over time. To find D, I cover up the D, and it's V times T. To find T, I cover up the T, and it's D over V. I won't give you that. You can memorize that if you want to. Actually, you get all the equations on your formula sheet. The green sheet that I gave you that has the radiation stuff on it has these equations on the bottom. Also, we talked about converting from kilometers per hour to meters per second. Do you remember how to do that? Okay, it has something to do with 3.6. That part is worth memorizing. Divide or times. Here's how I remember. What's bigger, kilometers or meters? If I think of kilometers as bigger, I can sort of think as meters as smaller or below. See that little picture that I drew? To go from kilometers to meters, divide by 3.6. To go from meters per second to kilometers per hour, times by 3.6. I just remember the bigger one is kilometers, so you're going to divide. That's a lie. In Physics 11, I'll give you a better way, but this is Science 10. Okay? So, Miller, you will have to remember, the number 3.6 has something to do with it. And by the way, it's a 3.6 because you're actually multiplying by 1,000 and dividing by 3,600 because there's 3,600 seconds in 1 hour and there's 1,000 meters in a kilometer. But when you times by 1,000 and divide by 3,600, that's just the same lower as dividing by 3.6, which is a little easier to remember. Convert 75 kilometers per hour to meters per second. Am I going to times by 3.6 or divide by 3.6? "75 kilometers per hour is how many meters per second?" And a lot of these won't work out evenly. Some will. What's the answer? I gave you calculators. Sorry?
20.83.
Sorry?
20.833333.
How about 20.8 meters per second? Close enough. 20.83.03 of a meter, that's like centimeters. I don't think we're that accurate when we drive. 95 kilometers per hour, how many meters per second? How about 26.4 meters per second? So a dog takes 4 seconds to run forwards 14 meters. What's its average velocity? Give your answer in meters per second and kilometers per hour. So the first thing we want to figure out is we want to ask, what are they asking us to find? No, I was careful. I didn't say speed. Okay, so I'm going to write down v equals question mark. What have they given me? I see a 4. What's that for? What's that for? This should do time. And I see a 14. What's that 14? 14. That doesn't quite work. By the way, since they said forward, I think you could argue that it's a displacement. It's a positive 14, but I'm not going to be that fussy. Velocity is distance over time. It's going to be 14 divided by 4, which is what? 3.5 meters per second? Oh, they also wanted this in kilometers per hour. What? Times by 3.6 to go backwards. So 3.5 times by 3.6. How many kilometers per hour? So is this dog road legal? No, this dog's not keeping up with traffic. 12.6, is that what it was? So on your test, you can definitely expect, I'll give you an answer in meters per second and say convert to kilometers per hour, or vice versa. You know what? Probably one of each. Turn the page, or next page over. A boat travels 280 meters east in a time of 120 seconds. What's the boat's average velocity? What are they asking me to find here? So what's this 280? Technically a displacement. What's this 120? Time? All right. What's the average velocity? Mr. Dueck? Yes, Brendan. Do we have to write out the formula every single time? You know, in your homework, I won't freak if you do. Brady, in our notes, we will, so that when you're studying, you know what the heck we did. And probably on a test or a quiz, I would, just to make sure I don't make a mistake along the way. In your homework, if you went straight to writing V equals what over what? 280 over 100. If you went straight to that, if you didn't write this line right here, I'm not going to freak. 280 divided by 120. Can I do that in my head? It's 28 over 12, which is the same as 14 over 6, which is the same as 7 over 3. Is the answer 2.66666? 2.333. I'm sorry, you're right. 2.33333? Do it. Units? That's the speed. How can I turn a speed into a velocity? Direction. What is the direct? That's in meters per second. How can I change that to kilometers per hour? If you have that answer still on your calculator, 280 divided by 120 times by 3.6. East. What's the displacement of a bicycle that travels 8 meters per second north for 15 seconds? What are they asking me to find here? Oh, let's write down d equals question mark. So I'm looking for the equation that has the d by itself, which I think is this one, yes? It's vt. So that must mean they gave us the v and the t. What's the v? 8. What's the t? So it's going to be 8 times 15. 120? Double check me. Yeah? 120 what? That's a distance, not a displacement. How can I turn it into a displacement? I need a direction. Is that okay? So we're doing some applied math here. Oh, they didn't say convert to kilometer, right? So we're good with that. Try the next one on your own. Can I do this in my head? Sure I can. 6 times 12 is 72. 0.5 times 12 is 6. 78? Double check. Yes? Yeah? 78 what? Meters? Direction. Mr. Dueck, could I call that negative 78? Technically, but if they give you a west direction, put the little west in brackets. That's clearer. What's the next question asking me to find? Time? Do I have an equation in my little box that has a t by itself? Yeah? Well, then let's go. Let's not waste any time. Tough audience. Can I do that one in my head? Well, 12 divided by 0.8 is the same as 120 divided by 8, which is 60 divided by 15. Mr. Dweck. 15 what? Direction. Time is a scalar. It can't have direction. Told you. I'd probably give you the frowning of a lifetime. 3 more, we're done, finally. You've been very patient. A car is driving forward at 15 meters per second. How long would it take the car to pass through it? Oh, did someone say how long? Is that right? 11 over 15? Ooh, can I do this one in my head? Oh, I don't have any good tricks for dividing by 15. It's dividing by 5, then dividing by 3. Dividing by 5 is going to be 2.2. Divide that by 3. Ooh, well, 22 divided by 3 would be 7.3. 0.73333?
Yes.
Ooh.
You are our winner.
When I shut my eyes completely, then you know I'm actually having to concentrate. Direction. It's a scalar. So I've asked you to find time. I've asked you to find distance. I've asked you to find velocity. A couple more. Hey, we'll skip the truck. Let's do the airplane. There is a problem with this question. Can anybody see what the problem is with this question? I got no problem with kilometers. What? I have 2 different time units. The speed was given to me in kilometers per hour, but the time was given to me in minutes. I need to get these in the same time units. Divide what by 24, where, how, what? There's a few ways to do this. Method 1 is to change minutes to hours, and then we're good. It's going to be a decimal, and you actually know how to do this even though you've never actually done this consciously. Ready? 60 minutes. How many hours? 120 minutes. How many hours? Mathematically, what are you doing with 120 to get 2 as an answer, or 60 to get 1 as an answer?
Divide by 60.
Dane.
Divide by 60.
5 minutes. How many hours? Dane. Same thing you just said.
You're going to divide by 60.
Divide by 60. By the way, whenever I got to convert something, Dylan, if I don't know what to do, I'll go to numbers that I already know. Oh, by the way, 15 minutes? What fraction of an hour is 15 minutes? You all know this one. Quarter of an hour? Try going 15 divided by 60. Does that give you 1 quarter? Gives you 0.25. So we've confirmed it? Okay. So, first of all, they want me to find this. t equals 5 minutes, divide by 60, and that'll give us hours. It's going to be a decimal. Hopefully a nice decimal.
0.083.
Now, I want to try and avoid rounding off if I can, because I don't want to introduce error. On my calculator, I have an answer button. If you don't have an answer button, I would use 0.0833333. I'll probably use about 5 threes, and then I'm probably good to go. The speed, actually the velocity, because there is a direction they gave me, is 480. Distance equals velocity times time. Actually, it's a displacement. Velocity, 480. Time, 0.083333333. Shut up, 3, etc. It's this times 480. How far do we travel in 5 minutes? How do you know? Oh, yes. It's displacement. There's our direction. Okay. That's a little mixing and matching. What's your homework? 2 things. And then I'll turn you loose. So what's your official homework? What's due at the beginning of next class is this practice take-home quiz. It's got some heft, some stuff to it. So analyze this graph the same way as we did in our lesson today. So between 0 and 6 seconds, tell me the slope, tell me the velocity, including the direction for each one of those time intervals. Ooh, there's going to be some negatives. Now, look up, all of you, please. I couldn't get it to photocopy darker. There is a line right there. I don't know if it really appears on your graph, but from 16 to 18 seconds, it is horizontal 0 high. Okay? Then, number 2, calculate, Mr. Dewick, the displacement for each of the time intervals. How far have you traveled for that section? I think you can get that by just looking at the distances traveled from the y-axis. If you can't figure it out, we'll talk about it on Friday. Number 3 asks, what's the total distance traveled? See if you can figure that out. Then turn the page over. Turn the page over. Here's another graph. I've given you 1, 2, 3, 4 lines. Match each of the following lines to the appropriate, each description to the appropriate line. So one of them is the object starting at the origin and traveling south with uniform motion. One of them is the object starts 2 meters south and travels north with uniform. See which one of those you feel matches which is which. And then, once again, here's another position versus time graph. Use the graph to complete the following table. So find the slope. Find the average velocity, slope to velocity, slope, velocity, slope, velocity. That's what I'd like to start class Friday going over. If you finish that, the homework that I handed out last class, which was section 8.1 homework part 2, all of that is now, as far as I'm concerned, fair game. Okay? I have talked way too much, although we did watch a video in the middle. I am done.